Welcome to video 3. Today we're going to talk more about the skills that you need for factoring. Last unit we talked about perfect squares or the VIPS list. For factoring, you need to be able to recognize those perfect squares and work on taking the square root of those perfect squares. So if the term is a perfect square below, take the square root of it. If it's not, then we're going to just leave it alone. So I'm going to do a few examples, and then you're going to finish them up in class when we come together tomorrow. So I'll do the first row here. So the square root of 36, is 36 a perfect square? Yes, it is, because it's on the VIPS list. So when I take the square root of 36, I get 6. And then 54. If I think of 54, remember we can look at our VIPS list by putting it in our calculator. Y equals x squared. And then we can look through and we'll see all of the numbers as the x values and then the perfect squares as the y's. So when I look at that list, I don't see 54 on it. So I can't take the square root and just have it be a number. It would be one of those situations where I'd have to simplify the radical. But the directions here was only to take the square root if it was a perfect square, and if not, then to just leave it alone. So for B, I can't do anything. For C, x squared, remember the rule for variables was that we look for even exponents. So since 2 is even, that means it is a perfect square. So I can take the square root. And then the square root of x squared is just plain old x. So that's my answer there. For D, again, we have to look at the exponent since it's a variable. X to the 7th, well, a 7 is odd, so I cannot take the square root of it. So for D, we're going to leave it alone. We cannot take the square root because it's not a perfect square. Next part, we're going to skip E through H. You're going to do those when you first come in tomorrow. This next part says to create an X diagram for each quadratic expression. So remember, in order to do that, we're going to write our X diagram. And then we put at the top A, C, and at the bottom B. So then in order to use this, I have to identify my A, B, and C values in the quadratic. And we also can remember that the A value is whatever the number is with the x squared. So the coefficient here is 3, so the A is 3. Then B, the number that is with the x, the coefficient there is 10. And then C is our constant, the number all by itself, and that's an 8. Once I've figured out A, B, and C, I can now go ahead and fill them in the parts of the X diagram. So A times C, 3 times 8 is 24. So 24 goes in the top of my X. And then B is the B term, 10, that goes in the bottom part of my X. So now remember, we want two numbers that have a product of 24 and a sum of 10. So we have to think of the factors of 24. And remember, you can also get those by using your calculator. Take the number that you're looking for the factors, 24 in this case, and then divide by x. Then when you go to your table, if you look, if there's a whole number, that means that it is a factor because it divides in evenly. So then we could look there if we needed to, or just think of what the factors are. The first one that works would be 6 and 4. So 6 times 4 is 24, and 6 plus 4 is 10. And now I have my X diagram all filled in. I'm going to skip B, and you're going to do that tomorrow when you come in as well. Number 2 says find the missing dimensions of the boxes below by working backwards and express it as a product of the two factors. So when I look here, 3x times what gives me 6x squared? Well, that would be a 2x. And then we need to fill out the top here. 3x times what would give me 27? Well, that would be a 9 since I already have the x. So now I have my two factors. I just have to write them as the factors. Now, I know usually I start with the top, but since this is just by itself, I put that out first, and then the 2x plus 9 needs to go in parentheses. And then that's my answer, the 3x times the 2x plus 9. Remember, the 3x can go in parentheses also if you would like. The last part that we're going to do here is finding the GCF. Remember, the numbers 6 and 9 you can put in your calculator. So the greatest common factor between 6 and 9 is 3. And then I look at the variables, x squared and an x. Well, the most I can take out would be the 2, the x squared, so x squared. And then y, because there's only one y common. Okay, we'll do more of this tomorrow. Have a good night.